Let's take a look at second problem of LeetCode contest, which says sum of subarray ranges. In a quick way, if I tell you, this problem is asking us to go over every subarray of this given array. Subarray is a contiguous part of the array. So we have to go over every subarray. In those subarrays, we have to find minimum and maximum. And the difference of that is called range. So for example, if I see from 0, there are three subarrays start at index 0. So this is first subarray of size 1, this is second subarray, and this is third subarray. So eventually this is 1, this is 1, 2, this is 1, 2, 3. It starts at index 0. That's what we are marking here. Same way, subarrays starting at index 1 are only single element subarray or two element subarray. So there are two subarrays which start at index 1. Same way, there is only one subarray which starts at index 2. So this subarray is 3, and the previous two subarrays, if I write, the subarrays are 2 and 2, 3. Now usually if we want to generate every possible subarray of the given array, it takes n cube time complexity, and n cube would become TLE for this problem because the constraints given are up to 1000. So we have to figure out how can we kind of solve this problem in better time complexity than n cube. So one idea is, let's consider every sub array, but what we can do, we can use a technique where when we have answer for first sub array, when we know minimum and maximum of first sub array, for example of 1, the minimum for 1 is 1, maximum is also 1. Now if we extend it to 2 size sub array, we can update minimum and maximum both. So if you see, minimum will remain to be 1 if 2 comes into picture, and maximum will change to 2 up to this point. Same way, when we extend this subarray to third element, minimum will continue to remain to be 1 and maximum will become 3. So with every subarray starting from index 0, if we can maintain minimum and maximum, that would do the needful for us. So what we essentially do, let's consider every index of this array as a start index. So it is like, thinking wise, if I just see, I will treat every element or every index of the array as start index, Si, from 0 to n minus 1. For every such index, what I will do is I will consider sub array of size 1, 2, and 3. So let's take, at this moment, let's take a maximum as, if array is named as A, we all know that with one size, maximum will be ASI and minimum will also be ASI. So we consider current element to be the maximum as well as minimum. And this point onwards, we start expanding it to size 2, size 3, and so on. At this moment, we know the difference is going to be 0 for this, and we have to find the difference, and that difference value we have to add. So this value will not differ at all. It is only one element. And finally, we have to get the sum. Let's take sum as 0. So we start with sum 0. We start with Si as the start index of any subarray. So initially, we are taking a look at 3 subarrays which start at index 0. We have taken min and max. Now we can have a varying thing for n index. So if I take n index to be, if we are starting at Si, n index can be Si itself, but we don't need to consider one size subarray. The difference is anyways going to be 0. And then we take 2 size subarrays. So that means Ei's starting point will be Si plus 1. And it will go up to n minus 1. Now here, when we are extending EI, again we can update our max. So max will be nothing but it will be max of the previous max, comma, current A of EI, because EI we are bringing into the picture. And same way, minimum also we are updating because it is possible that next element is minimum. For example, if array was 2, 1, 3, when we come to 1, minimum gets updated rather than maximum. So then we are updating minimum also, min of mn, comma, A of EI. Now, whatever mn and mx we got here, these mn and mx are for the next subarray. And within this loop, if I just try to get max minus min, this is something that we are planning to get into sum. So it is sum plus equals to this. So sum will keep getting updated here, and outside these two loops is where we can actually return the sum. So now if you think carefully, what will happen? Initially, our sum is 0. Our starting point we are taking to be 0, and max and min are 1 and 1 only. Then we keep moving, keep extending EI. So EI is initially at 1. So we say max becomes 2 and min remains 1. Now 2 minus 1, 1 gets added to the sum. So that is the sum gets 1 added to it. Next, we are extending EI again. And when we are extending EI to 2, we are saying, okay, now 3 comes into the picture. So 3 will be compared with previous max, which is 2. 2 and 3, max is 3. So max gets updated, min remains 1. So 3 is max, 1 is min, 3 minus 1 is 2. That is what we add here, because that's the 3 size subarray range according to the problem statement, that we got a range of that. Now all the subarrays starting at index 0 are done. Then we go up again. This time we start with red subarray starting at index 1. So Si becomes 1. We start with max and min as A of 1, A of 1. And now our EI starts from 2. So here out of 2 and 3 we'll update maximum as 3, minimum will become 2. So 3 minus 2 will become 1, and we are adding one more here. Then EI is at 2, EI will go further and it will go outside the array index. Then we go to SI, SI becomes 2 now. So when SI becomes 2, essentially if we wanted to optimize, we could have cut down outer loop to run for n minus 2 times, because anyways for last index there is one subarray that starts at it. So whatever answer we got here, that's the final answer, which is 4. And if we carefully look at this two nested loops where we are shifting EI to cover every subarray, and whenever we are shifting EI, we are getting the answer for next subarray. Like first we have answer for one size subarray, then 2, then 3. So we keep on extending the answer. So this solution of two nested loop is roughly n square solution time wise, and we are not using any extra space. So space wise this is constant. So this solution will get accepted for the constraints that are given. So array size is 1000 square will just be 10 power 6, and elements can be positive, negative, that doesn't matter. We are anyways subtracting max minus min. So this is how we can solve this problem in an elegant way. And here is a quick glimpse of the code I wrote and submitted during the contest. So I did not do an optimization of starting EI from SI plus 1. I just went ahead with int max and int min value, and it's just the same code that got accepted.